Hey guys, welcome back. So we're moving right along, and now I wish to talk to you about endothermic and exothermic processes and state functions. Alright, so an endothermic process is simply a process in which energy is being transferred into the object. One thing I should point out actually is systems and surroundings. Okay, a system is simply what we choose to study, something that we choose to study. It can be an open system, a closed system, or an isolated system. And this actually isn't in the book. I don't think it is in the book. I actually learned all this through different sources. A closed system, actually, let's start with an open system. An open system can be the corner of your room, okay? The air in the corner of your room. That is what you are going to study. You classify that as the system, okay? And it is an open system because matter can move in and out, and energy can move in and out, okay? Now, moving on to a closed system. A closed system means that you actually covered up the corner of the wall, and you closed in the air, okay? So no air is coming out and no air is going in. That is a closed system. But the key is here that energy can still go in and still come out of the system. Now we go on to the isolated system, and as you can guess, an isolated system is a system where energy and matter cannot transfer into it or come out of the system. And that's basically now, system and surroundings. The system is specifically what you're studying. The surroundings is everything else. Okay, so if you add the system plus the surroundings, it equals the universe. Okay? And your system can be anything you wish to study. In my example, the corner of my room. Okay? If I classify my system, it could have been several different things. It was pretty ambiguous how I said it. It could have been just the air, or it could have been the air and the container that I was using. So you have to be specific about what you're classifying your system as, because the corner of my room could have been just the air, or the air in the wall, or the air and the wall and like whatever I covered it up with, because that matters in the sense that the wall can still be can still take in and out energy, okay? So it matters in the classification of your system. So now moving on to endothermic and exothermic. Endothermic is simply energy is coming in. Exothermic is simply energy is leaving the system, okay? And it's simple enough to remember. Exo, exit, okay? And endo is just coming in. That's simple enough. Now, a state function is the last thing that I wanted to talk to you about. And the way that the book explains a state function, which I thought was a pretty good way, is the heating and cooling of water. Imagine you have water that is really cold and water that is really hot, nearly boiling, okay? And now, they are both going to, if you leave them out in a room, reach the room's temperature, okay? Which is about 25 degrees Celsius. So, the cold one will take in energy from the surroundings into the system, endothermic, and the hot one will give out energy into the room, okay, exothermic. One thing that is really intuitive, and I forgot to mention, but like I said, it's intuitive. Energy, or heat, more specifically, heat always moves from the cold to, from the hot to the cold, okay? So if you have ice and it's in a warm room, the heat will go into the ice, okay? So if you have ice and it's at 0 degrees Celsius and you put it in a freezer, okay, that's -5 degrees Celsius, the ice will actually give energy out, okay? And the ice will stop giving energy when they both are at the same temperature, okay? So that's why your coffee, if you leave it out, will eventually reach the room's temperature, all right? And So now explaining state functions. If you have your ice and you have your boiling water, they will reach the same temperature after time. Okay? So now, a state function is a state function is just the property of the system reaching the temperature. So say the system was originally 0 degrees Celsius and it goes to 50 degrees Celsius. Okay? You don't know what this arrow went through. Okay? This kind of implies, you could say, that it went straight from 0 degrees to 50 degrees. Okay? So let's plot it like this. This be temperature and this would be time. Okay? It's at 0 here and 50 here. Okay? So after time, this looks like this. Okay? It's steadily increased. But a state function and this right here doesn't necessarily tell you that it went straight there. It could also mean that it dropped down, came back up, did all this, and finally ended at 50 degrees Celsius. Okay? So a state function doesn't care where and how it got to the temperature. It just cares about this, the distance. It cares about this here. Okay? The change, this is delta, and it means the change in temperature. Okay? And that is a state function. It just means that you don't care where or how it got to the temperature it is. You just care about the change from the initial to the final. And that's it.